This is Unit 3, Day 3, Part 2. Okay, so we were just talking about, well, what happens if your leading coefficient is no longer a prime number? Well, we're still going to treat it the same way and do a slip and slide. So if you slip out the 15, you're going to copy it down as x squared plus 13x, and don't forget you're multiplying 15 times 2, it would be plus 30. Okay, so now we're going to factor old school. So you're going to say what multiplies to 30 but adds to 13. Well, 10 times 3 is 30, and 10 plus 3 would add up to 13. Okay, then you have to slip the 15 back in front of each binomial. So you're going to get 15x plus 10 and 15x plus 3. Now you have to reduce your binomials, okay? So 15 and 10, you have to divide out or reduce them. But again, if you need help, use the GCD key in the calculator, and you would just put in GCD 15, 10, and it would tell you what is the greatest common divisor between 15 and 10. Okay, so 15 and 10 can both be divided by 5, and if you divide each by 5, you're going to get 3x plus 2, and then in this binomial, 15 and 3, you divide out by 3, and you're left with 5x plus 1. So there's my answer. Again, you can always check yourself by foiling or box method, and you'll end right back up with the original trinomial. All right, part B. Again, slip out the 10. You're left with x squared plus 13x. And then you multiply 10 times 30, and you're going to get negative 300. All right, two sets of parentheses. And then you're going to say what two numbers multiply to give you negative 300 but would add to positive 13. It ends up being 25 and 12. Because 25 times negative 12 is negative 300. But then 25 minus 12 is positive 13. You slip the 10s in front of the binomials. And then you reduce each binomial. So 10 and 25 can both take out a 5. And you're left with 2x plus 5. And 10 and 12, you can divide both by 2. And you're going to be left with 5x minus 6. Okay, and again, I know many other teachers don't like this method, but I think kids have success with it and they like it, so why not use it? All right, part C. Slip out the 12, rewrite it as x squared plus 8x, and then you multiply 12 times 15, and you're going to get negative 180. Factor these, and you're going to say what two things multiply to give you negative 180 but would add to 8. It ends up being 18 times 10. 18 times the negative 10 is negative 180, but 18 minus 10 is positive 8. Slip the 12 back in front of each binomial. Last step, reduce. So 12 and 18, divide them both by 6. And you're going to get 2x plus 3. Second binomial, 12 and 10. You divide them both by 2, and you're going to get 6x minus 5. Okay. Moving on to part D. Part D, slip the 36 out. You're left with x squared minus 35x. And you multiply 36 times 6, and you're going to get 216. So you're going to say, what two numbers multiply to give me a positive 216, but then would add to a negative 35? All right, well, it's going to be 27 times 8. A negative 27 times a negative 8 would be positive 216, but a negative 27 minus 8 would be negative 35. Slip the 36s back in front of each binomial. And then reduce, okay? So 36 and 27, you can divide them both by 9. You divide them by 9, you're left with 4x minus 3. 36 and 8, you can divide them out by 4. And you're left with 9x minus 2. Okay, so that's the slip and slide method. All right. Next section here, for example 18, it's complete factoring. All right, so what they're going to want to do here is they want to verify that both of the following products are correct factorizations of this trinomial. Hint, FOIL. Okay, so you're going to want to just perform FOIL on both of these. Okay, so my first terms, I'm going to get 2x squared My outers, I get plus 2x. My inners, I get minus 6x. And my last, I get negative 6. Okay? I combine these, and I'm going to get 2x squared minus 4x minus 6, which is what I started with up here. Okay? Next thing, same thing. First, 2x squared, outer minus 6x, inner plus 2x, last minus 6. Combine like terms, I'm left with 2x squared minus 4x minus 6. So part B says, why are neither of these completely factored? Okay, well, if you look at the binomial in the first one here, if you look at this binomial 2x minus 6, there's still a factor here. 2 and 6 still have a number in common. So if you're to divide both those by 2, you're left with x minus 3. That's why it's not completely factored. Okay? And then if you look at the binomial over here, this is 2x plus 2. So if you had a 2x plus 2, that can be reduced even more with a GCF of dividing by 2. You divide it by 2, you're left with x minus 1. Or I'm sorry, x plus 1. Okay? So basically, it says, why are neither of these completely factored? Well, because the binomial 2x minus 6 and the binomial 2x plus 2 are not simplified. And I just showed you how it could be simplified more. That's why they're not completely factored. Part C, write each of the products in Part A in completely factored form by factoring out the GCF of each unfactored trinomial. Okay, so I kind of just did that for you. So the 2x minus 6 from that first example, you could factor out a 2, and you're left with x minus 3, and then they already had x plus 1 as a binomial. And the second one, we already talked about how in the 2x plus 2, you could factor out a 2, and you'd be left with x plus 1, but then you're left over with the x minus 3 binomial. Okay, and if you guys look, these are identical. So Part D says, what is true of both complete factorizations you found in Part C? They are the same factors. So this is 2 times x minus 3 times x plus 1. This is 2 times x plus 1 times x minus 3. And don't forget, multiplication is commutative, so you can switch that order. All right, the last little blurb box here. In practicality, it is always easiest to complete factoring by looking for the GCF first. Okay, that's huge. So pay attention. You always want to factor out a GCF first. It says once removed, then the factoring then either consists of a difference of a perfect square or a trinomial. So moving on to 19. Write each of the following in its completely factored form. Guys, when you see completely factor completely, it means usually there's 2 steps. So you're going to do a GCF, then a DPS. Or you're going to do a GCF, then a trinomial. Or a GCF, then a slip and slide, which is still a trinomial. Okay? So we're going to do that. So always run your GCF first. Alright? So part A, you can factor a 4 out of all of these. So when I factor out a 4, I'm going to be left with x squared plus 3x minus 10. Now, this is a trinomial. So I'm going to say what multiplies to negative 10 but adds to positive 3. So you need to keep and carry the 4 along for the ride, and then you're going to factor like how we did over in example 15. Okay? So I know that 5 times 2 is 10, but I also know that 5 and 2 can combine and give me a positive 3. So it's going to be plus 5 minus 2. Here's my final answer. Okay? Part B, factor out a 6 through GCF. If I divide each of these by 6, I'm left with x squared minus 4. This is a difference of a perfect square. So I keep and carry the 6, and that's x plus 2, x minus 2. And I did the lesson on that yesterday on day 2. Part C, you know it's going to be a GCF then a trinomial because there's 3 terms. So you factor out a 2. You are left with x squared plus 10x plus 25. Okay, this is now a trinomial. So you're going to say what multiplies to 25 but adds to 10. So that becomes x plus 5 and x plus 5. Because 5 times 5 is 25, but 5 plus 5 is 10. Last one, GCF out of 3. So divide each of those by 3, and you're left with 25 minus x squared. This is a DPS left over. Okay, so keep and carry the 3. Only thing you have to be careful with, this gave the number first. So the square root of 25 is 5. Those are your first terms. One's plus, one's minus. Square root of x squared is x. So there's my final answer. Example 20. Completely factor each of the following. These will involve final trinomials that are more difficult to factor, guess, and check. Okay? I just touch a slip and slide. So if we can slip and slide it, we're going to slip and slide it. All right. So part A. Part A, I'm going to factor out of 5. When I factor out of 5, I'm left with 2x squared plus 11x minus 21. Okay? This is now a slip and slide. Okay, the only thing you got to be really careful with, that 5 that we just factored out through GCF has to be written down in your final answer. Okay, so when I slip and slide that, you slip out the 2, you're left with x squared plus 11x, and 2 times negative 21 is going to be negative 42. Okay, so I'm going to old school factor this. I'm going to say what multiplies to negative 42 but adds to a positive 11. It ends up being 14 times 3. I slip the 2 back in front of each binomial. I get 2x plus 14 and 2x minus 3. Okay, if you want to drop the 5 down in front now so you don't forget it, go ahead. That's way back from the beginning. Last step, I have to reduce the binomials. So keep the 5 outside in front. And in this binomial, I divide them both by 2. I'm left with x plus 7. And then nothing reduces in 2x minus 3. So there's my final answer. Okay. Next one, GCF out a 3 first. So if I take out a 3, I'm left with 4x squared plus 19x minus 5. Okay, leading coefficient's 4. So what I'm going to do is I'm going to slip and slide that. So it's going to be x squared plus 19x minus 20. Okay, because 4 times negative 5 is minus 20. Old school factor, you're going to say what two things multiply together to give you a negative 20. So it's going to be 20 and 1, but 20 minus 1 is 19. Slip the 4 back in front of each binomial. And then reduce. You might want to drop the 3 in front now. So this ends up being 3. And 4 and 20, divide them both by 4. You're left with x plus 5. And then 4x minus 1, nothing reduces. Final answer. Example 21. Consider the trinomial. 4x squared plus 5x minus 6. Okay. This says, does the trinomial have a GCF that can be factored out? Answer is no, because 4, 5, and 6 don't have anything in common that can be factored out. You could think that 4 and 6 have a 2, but you can't divide 2 into your 5, so it doesn't work. Part B, the two products listed below are not reasonable guesses for the factorization of this trinomial. Why? All right, well, the reason it's not is because these still can be reduced, okay? So those two binomials still have GCFs, which means they can still be reduced. That's why you know that it's not a reasonable factorization. All right, part C. Could a binomial of the form 2x minus a and 2x plus b, where a and b are both divisors of 6, be correct for this guess? Well, no, guys, because if it's divisible by 6, then again, that wouldn't be factored completely, because if something is divisible by 6, so whether it's 6, whether it's 12, then 2 and 12 or 2 and 6 can be reduced here. So the answer is no, it's not factored completely. Again, meaning it can still be further reduced.